Hello students. Important questions of chapter 3, that is current electricity. 5 marks questions are like this. Derive an expression for electric current in terms of drift velocity and number density of free electrons. That means you are going to arrive at the relation for current, that is I is equal to NEAVD. So this relation NEAVD, this relation is asked for 5 marks. Second one, assuming the expression for electric current, arrive at the expression for electrical conductivity of a material, that is sigma is equal to Ne square tau by m, this relation. And next one, deduce the expression for the equivalent EMF and internal resistance of two cells connected in series. So that is when two cells are connected in series, you have to arrive at the expression for E effective and R effective. And similarly, when two cells are in parallel, arriving at the expression for effective EMF and effective internal resistance is also very important. Compared to the series and parallel, this parallel is very important question. And fifth one is obtain the condition for balance of Wheatstone network using Kirchhoff's laws. This is also very important questions for 5 marks. Now let us go for 3 marks questions. So here the first one is, write any 3 factors on which resistance of conductor depends. See, we know that R is directly proportional to L, inversely proportional to area. So resistance of conductor depends on size and shape of the conductor, and it also depends on nature of the material. Next one, arrive at J is equal to sigma E, where symbols have their usual meaning, or derive the expression for current density in terms of electric field and conductivity of material using Ohm's law. Conductivity is sigma. So J is equal to sigma E. This is one of the very important questions for 3 marks. What is meant by drift of free electrons in a conductor? Explain. So you have to write the definition of drift speed, drift of free electrons. So you are explaining the drift of free electrons in a conductor for 3 marks. Derive an expression for drift velocity of free electrons in a conductor. So that is Vd is equal to E tau by m. This derivation is one of the important for 3 marks. Next, name the mobile charge carriers in metals, ionized gas and electrolyte. This is also one of the important questions. And write any 3 differences between EMF and terminal PD of a cell. You should make 2 columns and you are writing the differences between EMF and terminal PD. That is one of the very important question. Obtain an expression for current drawn by external resistance using Ohm's law. That is I is equal to E divided by R plus R, this relation, and arrive at the relation between terminal PD and EMF of cell using Ohm's law. Same, that the question is to find out I is equal to E divided by R plus R. Next 2 marks questions are like this. Define electrostatic potential, mention its SI unit, or large number of free electrons are present in metals. Why? There is no current in the absence of electric field. In the absence of electric field, what happens? Electrons are not moving in particular direction. So average speed is 0, and hence since there is no drift velocity or average velocity in the absence of electric field is 0, and hence current is 0. That means the electrons are not moving in particular direction to produce current. So rate of flow of charge is 0. State and explain Ohm's law. Statement 1 mark, explanation 1 mark. How does resistance of conductor vary with its length and area of cross section? As length increases, resistance increases, and as R is directly proportional to length, as length increases, resistance of conductor increases. As area increases, resistance decreases, because resistance is inversely proportional to area. Mention an expression for resistance in terms of resistivity and explain the terms. Resistance can be written in terms of resistivity, that is R is equal to rho L by A. Define electrical resistivity of a conductor. Mention its SI unit. So you have to write the definition of resistivity. Resistivity can be written as RA by L. So when area is 1 meter square and length is 1 meter, then resistivity can be written as resistance. So using this you can define resistivity, and its SI unit is ohm meter. Mention any two factors on which resistivity of a metal depend. See, mention any two factors. Resistivity depends on nature of the material. Resistivity is independent of shape and size of the material. It depends only on nature of the material, as well as it depends on the temperature. Write any two differences between resistance and resistivity. See, resistance depends on shape and size of the material, okay, whereas resistivity does not depends on size and shape of the material. So this is the main differences between resistance and resistivity. And its unit. Define electrical conductivity of a conductor. Mention its SI unit. You go through it. Define current density. Mention its SI unit. Write another equivalent forms of Ohm's law in terms of current density and conductivity. Yes, that is J is equal to sigma E. J is equal to sigma E is called as another form of Ohm's law. Write any two limitation of Ohm's law. That is one of the very important question. This is one of the important question. Write any two limitation of Ohm's law. And what are ohmic and non-ohmic device? Give an example for each. This is also very important. And draw VI graph. This is VI graph for an ohmic and non-ohmic material. See, ohmic means all metals are ohmic device. Copper, how the graph looks like for copper. Non-ohmic means semiconductor. Or alloy is a ohmic device. So how the graph looks like. Define the terms drift velocity, relaxation time. This is also very important. Define mobility. Obtain the expression for mobility of free electrons in terms of relaxation time. Mobility of free electrons in terms of relaxation time. See, mobility mu is equal to Vd divided by E. Whereas Vd can be written as EEM. Vd, how to write Vd? EE by tau by m, right? So that's why E get cancelled. So we will get E tau by m. Write an expression for resistivity in terms of number density and relaxation time and explain the terms. What is the cause of resistance of conductor? The cause of resistance of conductor is successive collision. Cause is collision between electrons and with ions. Write an expression for the resistivity of a metallic conductor showing its variation over a limited range of temperature and explain the terms. How does the resistivity of metallic conductor or copper vary with temperature? Show its variation graphically. So resistivity varies, how it varies with the copper. See, in copper what happens, as temperature increases, resistivity also increases, right? And how does the resistivity of alloy? In case of alloy it is like this straight line. And how does resistivity of semiconductor vary with the temperature? Semiconductor decreases. It decreases with temperature. Resistivity decreases with temperature. Define the terms electrical energy and electrical power. Mention the expression for power loss in a conductor and explain the terms. Power loss can be written as P is equal to I square R. This is power loss, I square R, or V square by R. V square by R. Explain the terms. Why high voltage power from power generating station is preferred than high current for transmission of electrical power? So what happens here, if high current is passing through the transmission wire, then what happens, due to its heating effect, the power will be lost in the form of heat. Okay, so that's why high voltage is preferred than high current. Okay, define EMF and internal resistance of cell. Terminal potential difference is less than EMF of cell. Why? Terminal PD is always less than EMF. See, that is because here EMF is a potential difference across the terminals of a cell. This is EMF. Whereas when current flows through external resistance, then what happens here, as the current is flowing through like this, here inside this cell there is a PD across the internal resistance. Due to internal resistance, or there is opposition offered by electrode and electrolyte of the cell, some internal resistance will be there in a cell. That's why some potential drop across the cell, and hence potential drop across this external resistance, that is called as terminal PD, is less than EMF. It is always less than EMF. Suppose if there is no internal resistance, then terminal PD will be equal to EMF of the cell. For what basic purpose the cells are connected in series and in parallel? In order to get required or effective EMF and effective resistance, or in order to get required value of EMF and internal resistance, cells are connected in series and parallel. State and explain Kirchhoff junction rule or current law. And this is one of the very important question. State and explain Kirchhoff loop rule or voltage rule. This is also very important question. And for filling the blanks, this question will also be asked like, Kirchhoff junction rule is based on law of conservation of. So current law is based on law of conservation of charge, and second one, voltage law is based on law of conservation of energy. So like this, here I listed out 2 marks, 3 marks, 5 marks, all important, most expected questions. I referred PYQs and here I listed all these questions. I hope it is helpful, and if this video is helpful, please like, share and subscribe my channel. Thanks for watching. See you in next video.